Hello students, welcome to my video lecture. First Brahmanath. Om Shanti Shanti Shanti. In last class we discussed a relation. Okay, the relation means it is the association between two elements of the sets. So let A and B are two non-empty sets, and R is a relation from set A to set B. Then R must be a subset of A into B. So R is subset of A into B. Capital A into capital B. Okay. Next, suppose small a belongs to capital A, small b belongs to capital B. If A is related to B by the relation R, then we say that order pair A comma B belongs to relation R. So R is equal to curly bracket order pair A comma B such that A is R related to B by the relation R. Next, domain, range, codomain, and also some particular types of relation, that means empty relation, universal relation, identity relation, inverse of a relation. Next, already discussed kinds of relation, that means one relation, one many relation, many one relation, and many relation. Today we are going to discuss function. Function is a special types of relation, and this is a very important chapter because this is the foundation of some topics of mathematics, some branches of mathematics like calculus, abstract algebra, real analysis, and so on. So function is a special type relation, means every function is a relation, but the converse may or may not be true. All functions are relations, but a relation may or may not be a function. Some criteria is there, some conditions are there. So say condition satisfy karibo, the relation ta ame kan kaiba function. Okay, so what conditions are there? Now a relation F, suppose A and B are two non-empty sets. Suppose A and B are two non-empty sets. Okay, if F such that A to B is a relation, then it satisfies. F such that A to B is a relation, and F satisfied two conditions. Condition 1, every element of set A are related to the element of set B. A रे जते सब एलिमेंट अच्छी सब रिलेटेड होगा का सहित सेट B सहित. Next, the relation is either 1 1 or many to 1. The either condition simultaneously satisfy करिबो, then the relation is said to be a function, otherwise it is a relation. Okay. Definition. Let A and B are two non-empty sets. Okay, a relation F from A to B, from the set A to the set B is said to be a function if every element of set A, every element of set A is associated with unique exact one element of set B, exact one element of set B with relation F, with relation F. Okay, that is, if we impose the above rule with relation, then the relation is a function. That is, if we impose the above rule, then the relation is said to be a function. Then the relation is said to be a function. Okay, function is also known as map or mapping or correspondence or transformation. Okay, और we say f is a function from A to B. F is a function from set A to B, set B we written as f such that A to B. Okay, if every element of set A related to if each element of set A related to only one element of set B, only one element of set B such that f of x is equal to y, such that f of x is equal to y under the rule f. Under the rule f, here x belongs to set A and y belongs to set B. X belongs to set A and y belongs to set where x belongs to A comma y belongs to B. X belongs to A comma y belongs to B. Okay. If f is a function from A to B and order pair x comma y belongs to f, then y is equal to f of x. So here y is called image of the element x belongs to A and x is called pre-image of the element y belongs to B. If f is a function from A to B and order pair x comma y belongs to f, then y is equal to fx. Here y is called image of x under f and x is called pre-image of y under f. Okay. Set A is called domain of f comma and B is called codomain of f and set of all f images of the elements of set A elements of set A is known as range of f, or image set of A under f and it is denoted by f of capital A, that is f of capital A is equal to f of x such that x belongs to capital A, which is subset of capital B, that is range of f is subset of capital B, means codomain or f of capital A is subset of capital B. range is always subset of codomain. Okay, देखा some notation देखा दीजिए notations f such that a to b, तो a is called domain, a is called domain, b is called कौन codomain, b is called codomain. Okay, a is called domain and b is called codomain. तो f is a function from a to कौन है जी b. Okay, तो this is the domain. Domain means set of all inputs, the input sets. Okay, this is x, means x belongs to domain. This is f is a function, means there is a machine. Okay, this is output. तो ये है हमारा कौन output sets. Output sets are known as range. तो y output set is known as y range. This is y is equal to fx. So this is output sets is equal to range. This is a range. This is x is called independent variable. X is called independent variable. Is called independent variable. But y is called dependent variable. Y is called dependent variable because y depends on x. Dependent variable. Y depends on x. So x changes, the y also changes. Hence y depends on x, so it is called dependent variable. But x is an independent variable. Okay. This is set A and this is set B. So A is called domain. This is called domain set. This is called codomain. Okay. Means every element of set are associated with each and unique, means unique element of set B, means only one element of set B. Like आर प्रत्येक एलिमेंट बी रो सिंगल एलिमेंट सहित कौन होता पड़ो एसोसिएट मीन्स रिलेशन रखुवा पड़ो. ओके, तो सपोज एक्स, दिस इज एक्स इज एन एलिमेंट ऑफ सेट ए. दिस इज वाई is equal to f of x. Okay, so x is called here x, y is called image of x, y is called image, f image of x, x is called pre-image of y under f. Okay, under f. A relation f such that a to b is a function if condition 1 domain of f is equal to set A, means every element of set A must related to unique element of set B. Condition 2, the relation is either 1:1 or many to 1. 1:1 रिलेसन होता पड़ो ना many to 1 रिलेसन होता पड़ो तो सीटा को आम कौन कह फंक्शन कह तो लिखु एवरी एलिमेंट ऑफ सेट मस्ट रिलेटेड टू द एलिमेंट्स कौन है एलिमेंट्स ऑफ सेट बी है ये कौन सेकेंड कंडीशन द रिलेशन इज either 1:1 और many to 1 ये दुईट जा कंडीशन साइमल्टेनियसली सैटिस्फाई कला तो से रिलेशन को आम फंक्शन कहवा अदरवाइज इट इज ए रिलेशन हेंस एवरी फंक्शन इज ए रिलेशन बट कन्वर्स may or may not be true okay this is some figures are given which of the following is a function if not why it is not a function with clarification okay देखो here given A and B set A contains 1 2 3 4 B contains A B C D condition 1 कौन कहूँ domain of function domain of f is equal to A domain of f is equal to कौन होता पड़ो A होता पड़ो देखो A contains 1 2 3 4 elements are there in set A so out of 4 elements only 3 elements related to the elements of set B so it is not a function because condition 1 not satisfied here condition 1 is what now domain is equal to total set A domain means every element of set related to the elements of set B so every element means out of 4 elements only 3 elements related 1 is not related to the elements of set B so domain is a subset of set A so condition 1 not satisfied not satisfied because 4 is not related to the elements of set B so condition 1 not satisfied condition 2 the relation is either 1:1 or many 1 so it is a 1:1 relation the condition 2 satisfied this is satisfied condition satisfied okay therefore question number 1 is not a function because condition 1 not satisfied condition 2 satisfied so not a function next question number 2 also condition 1 not satisfied because set A contains 1 2 3 4 5 6 out of 6 elements only 3 elements are related and next 3 elements not related to the elements of set B hence condition 1 not satisfied okay condition 2 satisfied relation is many to 1 or many to 1 तो ये many to 1 relation satisfied condition 2 satisfied तो it is not a function okay next question number 3 condition 1 not satisfied because out of 5 elements only 1 is related to the elements of set B rest 2 3 4 5 not related to the elements set B so condition 1 not satisfied condition 2 is not satisfied because one element of set related to more than one element of set B एथर गोटे एलिमेंट एपटर दुईटा एलिमेंट सहित कौन रिलेटेड रिलेशन अच्छी तो इट इज नॉट ए कौन condition 2 also not satisfied. Relation is either 1 1 hithe appudu many to 1 hithe appudu. So it is 1 to many achi. 1 to many. 1 to many. Hence it is not a function. It is not a function. Not a function. Next question number 3. Question number 4. Suppose 1 2 3 A B C D. 1 related to A, 2 related to B, 3 related to D, also 2 related to C. Condition 1 satisfied because every element of set A, every element of set related to the elements of set B. Every element of set A related to the elements of set B. So condition 1 satisfied because the domain of set A is equal to domain of F is equal to A. Domain of F is equal to A. Hello nahi? Here condition 2 not satisfied because 2 is the element of set A, 2 is related to B and C, means 2 related to both 2 elements, 2 related to more than one element relation achi. So not satisfied. 1 to many relation achi. Not satisfied. So not a function. Not a function. It is not a function. Kaiki the 1 to many relation. 1 to many. So it is not a function. Okay. Next, another four questions. Set A 1 2 3 4 B A B C D E. So set A, every element of set related to the elements of set B. Every element of set A related to the elements set B. So condition 1 satisfied. Domain is equal to set A. Satisfied. Next, the relation is 1 1 relation. Relation is what? 1 1 relation. Ye be satisfied. So it is a function. Is a function. Is a function. Okay. Next, question number 2. Every element of set related to the elements of set B. So condition 1 satisfied. Condition 1 satisfied. Condition 2 also satisfied because it is a many to one relation. Many to one relation. Many element of set A related to one element of set B. Okay, this is one. A many one. This is 1 1. So ये है many to one relation. So satisfied. So it is a function. Is a function. Next, question number 7. Condition 1 satisfied. Condition 1 satisfied because every element of set A related to the elements of set B. Condition 2 not satisfied. Not satisfied because it is a many function. 1 related to both A and B. Here 2 3 4 5 related to C. That's why 1 to many and many to 1. 1 to many and many to 1, it is called many. There are many relation. Many relation. Okay. So not a function. Not a function. It is not a function. Last one, both conditions satisfied. Both conditions satisfied. Okay. It is a function. Is a function. Is a function. So here is the difference between relation and function. Question number 7 is only relation. It is not a function. Hello. सबु जगह गोटे रिलेशन किंतु फंक्शन है कौन 5 6 8 ला फंक्शन तुम अदरार कौन सब ऑल आर रिलेशन किंतु 5 7 8 बोथ रिलेशन एज वेल एज फंक्शन 5 7 8. ओके. Suppose this is a set A and this is a set B. Okay. 1 2 3 4 5 6 7 A B C D E F G H I. So 1 related to B, 2 related to C, 3 also related to C, 4 related to D, 5 related to E, 6 related to G, 7 related to G. So it is a function because the domain of F is equal to set A, because every element of set A related to the elements of set B. Okay, and so this is called domain. This is called domain. This is called domain, and this is called codomain. Codomain and range set देखो ठीक है, ये लेता हूँ range set. ये जो set असला ये ला range set. This is called range of F. So a domain of F means a set that 1, 2, 3, 4, 5, 6, 7. A range of F means B, C, D, E, G. B, C, D, E, G. B, C, D, E, G. A range of F. Codomain of F means codomain of F means total set B, that is A, B, C, D, E, F, G, I. So clearly range is subset of codomain. Range of F is subset of codomain. Okay, so here f of 1, B is equal to f of 1, C is equal to f of 2 is equal to f of 3. C is equal to f of 2 and f of 3 means f of 2 is equal to C, f of 3 also C. F of 4, D is equal to f of 4, E is equal to f of 5, and G is equal to f of 6 and f of 7. Okay, so here B is called F image of 1. B is called image of 1 under the function F. C is called image of both 2 and 3 under the function F. D is called image of 4 under the function F. E is called image of 5 under the function F. G is called image of both 6 and 7 under the function F. Next, 1 is called pre-image of B, 2 and 3 are called pre-image of C, 4 is called pre-image of D, 5 is called pre-image of E, 6, 7 are called pre-image of G under the function F. Okay, so this is function. Next, equality of two functions. Equal functions. Two functions f and g. Two functions f and g from set A to set B. From set A to set B are said to be equal, are said to be equal if condition 1, if and only if condition 1 domain of f is equal to domain of g, f is equal to domain of g, domain of f is equal to domain of g. Condition 2, codomain of f is equal to codomain of g, codomain of f is equal to codomain of g. And condition 3, fx is equal to gx for all x belongs to set A. For all x belongs to set A. मीन्स एवरी आउटपुट्स आर आल्सो इक्वल एवरी आउटपुट्स आर इक्वल डोमेन जाक इक्वल होता पड़ो को डोमेन इक्वल होता पड़ो एवरी आउटपुट फॉर ईच इनपुट पे आउटपुट मध्य कौन होता पड़ो इक्वल है तो आम कौन कह टू फंक्शंस आर से टू बी इक्वल अदरवाइज दे आर नॉट इक्वल ओके एग्जाम्पल देख टे एग्जाम्पल लेट एफ सच दैट r minus 2 to r f of x is equal to x square minus 4 divided by x minus 2 x square minus 4 divided by x minus 2 and g such that r to r g of x is equal to x plus 2 okay test whether the functions are equal or not test whether the functions are equal or not answer domain of f here f of x here f such that r minus curly bracket 2 to r and defined by f of x is equal to x square minus 4 by x minus 2 so this is x minus 2 into x plus 2 divided by x minus 2 cancel so this is x plus 2 g such that r to r g of x is equal to x plus 2 okay both are equal but domains are not equal domain of f is equal to r minus curly bracket 2 domain of g is equal to real number r since the domains are not equal since their domains are not equal their domains are not equal so two given functions are not equal okay जेहेतु दुईटा डोमेन सामान नुहे तो दे आर नॉट इक्वल आउटपुट सामान आसुची किंतु डोमेन सामान नुहे ओके कहीं देख ये मुझे 2 पुट कर देख यही सेकेंड फास्ट केस रे मुझे एक्स रे 2 पुट कर कि सेकेंड केस रे मुझे एक्स रे 2 पुट कर तार अर्थ इक्वल केमती है ओके नेक्स्ट रियल वैल्यूड फंक्शन ए फंक्शन इज सेड टू बी रियल वैल्यूड फंक्शन if the domain and range of the function is either real number r or subset of real number r कौन कहला ए फंक्शन इज सेड टू बी ए रियल वैल्यूड फंक्शन if their domain if the domain of the function or means domain of the function and range of the function both are सबसेट ऑफ आर हो पारती किंबा इज इक्वल टू आर हो पारती मीन्स आर बाहर को जावाक हेनी ऑल आर सबसेट ऑफ रियल नंबर और इज इक्वल टू रियल नंबर देन द फंक्शन इज सेड टू बी ए रियल वैल्यूड फंक्शन ओके तो रियल वैल्यूड फंक्शन a function f such that a to b is said to be a real valued function if a and b are either subset of real number set of real number r or is equal to set R. Set R means both domain and codomain, that is domain and codomain are either equal to R, either equal to set of real number R or subset of real number R. Subset of real number R. ओके, ये कौन रियल वैल्यूड फंक्शन. तो बर्तमान आम जहाँ सब डिस्कसन करिया सब जाक रियल वैल्यूड फंक्शन को बेस करी ही करिबा है. मीन्स ऑल द डोमाइन एंड कोड डोमाइन all are subset of real number R or is equal to real number R. Okay. Algebra of real valued functions. Algebra of real functions. Algebra of real functions. Algebra means addition of two functions, subtraction of two functions, multiplication of two functions and division of two functions. Let f such that domain of f to real number R and g such that domain of g to real number R are two real valued functions. Are two real valued functions. Okay, functions. Where df means domain of f, where df means domain of f and dg means domain of g. Domain of g. Also df intersection dg is equal to x such that x belongs to df and x belongs to dg, which is not is equal to phi, means it is a non-empty set. Okay. तो फर्स्ट वन addition of two functions. Okay, addition of two functions. Addition of two functions. Okay, addition of two functions means दुईटा फंक्शन में ऐड करिबा. तो f प्लस g करिया में ना कि f plus g such that f plus g means add करुचे. तो डोमाइन टा कौन हम डोमाइन ऑफ df इंटरसेक्शन डोमाइन ऑफ g is the domain of f plus g to real number R. To real number R. Okay, we define f plus g. We define f plus g of x is equal to fx plus gx for all x belongs to domain of f intersection domain of g. मीन दुईटा फंक्शन केतला में ऐड करिबा जेतला सेमानंगर कॉमन डोमाइन टा हबो f plus g र कोन डोमाइन. मीन्स f plus g जे न्यू फंक्शन. तो न्यू फंक्शन डोमाइन टा कोन ना डोमाइन ऑफ f इंटरसेक्शन डोमाइन ऑफ g. ओके. सिमिलरली टू सब्ट्रैक्शन of two functions, same case, f minus g such that ये न्यू फंक्शन आसिला डोमाइन ऑफ f इंटरसेक्शन डोमाइन ऑफ g to real number R. We define f minus g of x is equal to fx minus gx for all x belongs to domain of f intersection domain of g. Third one, multiplication of two functions. तो ये कौन हम f इंटू जी सच दैट ये भी डोमाइन ऑफ f इंटरसेक्शन डोमाइन ऑफ g टू रियल नंबर r. to real number r. We define fg of x is equal to fx into g of x for all x belongs to domain of f intersection domain of g. Domain of f intersection domain of g. And last one quotient of two real functions. Quotient of two real functions. Quotient of two real functions. So quotient of f by g is denoted by quotient of f by g is denoted by f by g and f by g of x is equal to fx by gx. Condition g of x not is equal to 0. So domain of f by g is equal to domain of f intersection domain of g minus x such that g of x is equal to 0. तो ये लगा domain of f by g. तो ताले फंक्शन टा कौन हम f by g such that ये जो domain of f by g to real number r कौन r. तो domain of f by g is equal to domain of f intersection domain of g minus x such that g of x is equal to 0. Okay. Now next scalar multiplication by a scalar. कौन सा multiplication by a scalar. Multiplication of a function by a scalar. Okay. Let f such that domain of f to real number r and alpha is a scalar. Then alpha f is also a function such that alpha f such that same domain of f to real number r and alpha fx is equal to alpha fx means alpha times alpha into fx. So alpha times fx for all x belongs to real number r. Okay. In next class we shall discuss types of functions. Okay.